Hello, welcome to my demo video. In this demo video, I'm going to show how a device features can be remotely configured via smart contracts. Here, I'm going to use a Z-board as our device, which has an SoC consisting of a processing system and an FPGA. We implement our hardware design for remote configuration controller and the time enforcement controller in the FPGA and programmed it via Xilinx Vivado tool. This device interacts with a blockchain. We use the Ethereum Ring-B testnet for the purpose of our experiment. The device has an embedded smart contract address which it keeps polling periodically, and whenever there is any upgraded reconfiguration request by the user in the smart contract, uh, it fetches that and applies that. So here for demonstration we use like the LEDs, the built-in LEDs in the board. So we use like the right two most LEDs. So there are like three possible configurations we just demonstrate. So the default configuration is not any LED glowing. The next configuration is like the rightmost LED glowing, and the third configuration can be the rightmost two LEDs are glowing. So the smart contract was written using Remix Ethereum IDE. It was compiled and then it was like appended in the Ring-B Ethereum testnet. It is there whenever a smart contract is created, it gets an address. So in our case, the address of the smart contract is um, this one, which is this. So a user can use this contract address and request for any upgrade using his wallet. For wallet, we are using MyEther wallet. Here for demonstration, I'm using my account and just using the same contract address. So there are like few parameters LED turned on. So the smart contract has few functions. One of the functions is turn LED on, which is just for the purpose of reconfiguration of the device, the Z board. So the user requests for two possible upgraded configurations, one or two, and request for timer, the requested amount of time for which he wants to apply the reconfiguration to the device. Also, he has to pay some ether for upgrading the reconfiguration of the device. So for our case, like for first configuration, he has to pay minimum 0.1 ether, and for second configuration, he has to pay minimum 0.2 ether. So the interaction between the device and the smart contract or the blockchain happens via a blockchain node. Here, the Raspberry Pi is working as our node. So it's kind of working as a gateway. So many other devices like this Z-board can simultaneously connect to the gateway and get their corresponding configuration upgrades if the user of those devices request for it. So the Raspberry Pi is running a lightweight node. We have implemented the Go Ethereum lightweight node here. We can see the Raspberry Pi output here. So the Go Ethereum or Get light node is syncing with the Ring-B testnet, and it's only importing the block headers, not the entire blocks consisting of like several transactions and many other associated data. So that's why it's called lightweight node, because it's just syncing with the block headers, not the entire content of the blocks. So the device communicates with the gateway using an a Wi-Fi module, which is an ESP826601 device we use for that. So this is a Wi-Fi module, and the Raspberry Pi has also Wi-Fi. So through this device, which is connected to the Z-board via the PMOD connector, and communicates with the processing system, the SoC, using UART communication, universal asynchronous receiver transmitter. So via AT commands, the processor sends AT commands to the ESP module, and ESP module starts a TCP connection and post the HTTP request to the Geth node, the Raspberry Pi blockchain node, to get the smart contract request upgrade. So so for example, if we choose the configuration 1 and choose like 60 seconds and put Ethereum 1, 0.1 Ether value, and we write this smart contract, it will take us to the associated account in MetaMask browser extension and ask for a confirmation. If we confirm it, then pretty soon it will be appended to the blockchain, and as soon as it is appended to the blockchain, this device LED will glow. So the time of appending depends on the transaction rate of the Ethereum testnet. So for ring B, it's like about 10 seconds. So within few seconds it should glow on. So here we can see that the transaction is confirmed. So as soon as the transaction is confirmed, it is glowing, as we can see, and it should glow for about 60 seconds. So this is just configuration 1, which is the rightmost LED being turned on. So as we can see that after 1 minute or 60 seconds, it has turned off and it went back to its default configuration, which is not any LED glowing. So this is what our proposed protocol is in this work. So we can see another example. If the user requests for another configuration, like the second configuration, which is turning on 2 LEDs, and he can request for any number of time. For example, we can try with some different amount of time, which is 45 seconds. And for this upgraded configuration, he has to pay a little extra, which is 0.2 Ether. If again he writes this transaction and confirms it in his account, and as soon as it is appended in the blockchain, again similar to the previous configuration, this configuration will be upgraded in the device. As we can see, the transaction is confirmed, so soon we should see the 2 LEDs glowing. So yeah, we can see that the 2 LEDs, the rightmost 2 LEDs are glowing as per requested by the user. So again, it should glow for 45 seconds as requested by the user of this device, which is me. So after 45 seconds, again it will go to the default configuration, which is all LEDs being turned off. Yes, so we can see that it went back to the default configuration. So this is what we implemented in our proposed protocol for remote IC configuration. Here our we implemented the design in hardware. Also some part of the design consists of implementation in software, also in the processing system, like the decryption of the encrypted configuration registered by the manufacturer of the device. So the details of the hardware software co-design is found in the paper we have in the GitHub, and also we have other materials, the software and hardware design implementation, the Vivado files. So we can check it out there, and we can implement using the project files there. So thanks for watching the video. Hopefully this is useful. Thank you very much.